inferential statistics. Okay,
Okay.
and inferential statistics, it's all about doing experiments, um, making statistical claims, doing predictions, all sort of
Mm-hmm.
that stuff. Okay, so let's assume that, and these questions are really easy if you know there are some 4 rules that you should remember, and you'll be able to do any question. These questions are super easy. So let's assume that we want to find out the average height of all the men in the state of Texas, let's say. Average height of all the men in the state of Texas. Now, there are around 10 million men in Texas. Okay, there are around
Yeah.
10 million men in Texas. So, I think it won't be feasible for somebody to, to record the heights of all the 10 million men and then add all of the values and then divide it by 10 million, right? So in any type
Yeah.
of experiment, or maybe some survey, you can say, let's say this was a survey. So when the population is very big, now this is our population, this is our population. So when our population is very big, what we do is we take samples. Okay, so instead of recording the heights of all the 10 million men, what we can do is we can take samples. Okay, so we can take, let's say we can take 3 samples, S1, S2 and S3. Each sample has, let's say, 100 men. Okay, 100 men, 100 men and 100 men. Now, instead of recording the heights of 10 million men, what we can do is we can record the heights of 100 men in each of the
Mm-hmm.
3 samples, and then we can calculate the mean of each sample. So let's say the mean for sample S1 is M1, and then mean for sample S2 is M2 and M3. And then we can find out the mean of these 3 means. Okay, so M1 plus M2 plus M3 over 3. Okay, so there could be multiple ways of trying to find out the mean for a population. Like I just took 3 samples, you could take as many samples as you want. And now this mean that you will get, this is called estimated mean. This is called the estimated mean, and this is just an estimate of the true mean. Now let's say we get this mean as 5 feet and 5 inches, so 5.5 feet. Okay,
Mm-hmm.
so this mean tells us that the actual mean could be 5 feet and 5 inches, but we cannot say with certainty that the actual mean would be 5.5 feet, because this is based on 3 samples that we took. Okay, so
Mm-hmm.
would you agree if I say that there would be some error in this estimated mean? Like we don't know
Yeah.
what's the true mean. So whenever we estimate anything, like if we estimate mean or median or standard deviation, whenever we are doing estimation, there will be always a margin of error involved. Okay, it will have
Mm-hmm.
some margin of error.
Yeah.
Now if I say that the margin of error is 0.5 feet, let's say that the margin of error is 0.5 feet, so that means that the actual mean or the true mean could be 5.5 plus zero point 0.5 or 5.5 minus zero point 0.5. So the actual mean will lie in this range, in this interval.
Mm-hmm.
Okay, so that means that it could lie between 5.5 minus zero point 0.5 is 5, and 5.5 plus zero point 0.5 will be 6. So the actual mean could be anything between 5 to 6. It could be 5.1, 5.2, 5.3, 4, 5, 6, or 5.9. That's the meaning of margin of error. That's one thing. Okay, and the second thing is, would you agree, what would you say about margin of error? Will it be more if my sample size were, let's say, 10,000 men, or will it be less if the sample size had been 10,000 men? So now let's say I take 10,000 men in each sample. 10,000 men. So what will happen to the margin of error? Will it increase or will it decrease?
It would decrease because like
Hmm.
the sample size is getting bigger, so like it's getting more specific.
Exactly. So if we are increasing the sample size, that means we are getting closer to our actual population, which was 10 million. And if I, instead of 10
Yeah.
million, instead of 10,000 men, if we take a sample of 1 million men, then margin of error would be even less. So the error
Yeah.
keeps on reducing when we keep on increasing the sample size. So that is your number one rule, that your margin of error, MOE, let's denote it with MOE, it's going to be less if the sample size, so they are inversely related, if the sample size is more, and margin of error will increase if sample size, if we have a smaller sample size. That's rule number one.
Hmm.
Rule number two is, this sample that you're taking,
So,
okay, okay,
so
so we did one rule, that margin of error will be less if the sample size would be bigger, and margin of error
mhm.
will be more if sample size would be smaller. Well, this is actually rule number two. Your rule number one will be that these samples that you're taking, these samples should be random samples. Okay, so the samples should be random samples. What do you understand by random sample, Kevin?
like they're not like specific to like one like type of people. Like
Mm-hmm.
for this in this case, they should be like all like of like the sample would be like just men in general in Texas. Like they shouldn't
Mm-hmm.
be like specific to like what type of men in Texas.
Exactly. So, for instance, if we had taken a sample of men who are athletes, uh, generally, athletes tend to have more height than an average person, right? Athletes are
Yeah.
taller. Or
Hmm.
if we had taken a sample of, let's say, stewards, right? Stewards are
Hmm.
also taller than an average person, because there's actually some a condition for someone to become a steward. They have to have some minimum height in order to qualify for the job of a steward. So stewards would be taller.
Hmm.
So if we had taken a sample of stewards or athletes, then we would have gotten a higher mean, higher than 5.5. So that would have
Yeah.
been a biased sample, right?
Hmm.
So we don't have to take a biased sample. We have to pick up people randomly in the samples. So that will be a rule number one, that you have to pick up a random sample. And the rule number three is, this result that we are getting, this estimated mean that we are getting, well, on the basis of this mean, we can claim that the actual mean or the true mean of all the men in Texas would be between 5 and 6. Now, this result only applies to this population from which we have taken the samples. This result will
Hmm.
not apply to any other population. For example, now if we say that all the men in the state of California will also have a mean of 5.5 feet, then we cannot make that claim. Okay, so
Yeah.
the population from which we are taking the sample, the result will be applicable to only that population. That's rule number
Mm-hmm.
3. And on the basis of these 3 rules, you can solve any question based on inferential statistics. So it says that results of the experiment or the survey will be only applicable to the population from which we are taking the sample. From which we have taken the sample. Okay. Alright, so let's do some practice questions to get an idea of how the questions are framed.
Yeah.
Okay, and even when we are saying that the actual mean would be between 5 and 6, again it's a possibility that the actual mean would be 5 and 6, because it's based on only these 3 samples. Okay, so we cannot say with certainty that the actual mean will be definitely between 5 and 6. We cannot make that claim,
Yeah.
but it's just an estimation. Okay, so okay, so the first question type that I want to discuss is this one. So can you read this question, Kevin?
Um, a sample of 40 fourth grade students were selected at random from a certain school. 40 students completed a survey about morning announcements, and 32 thought the announcements were helpful. Which of the following is the largest population to which of the results can be applied?
Okay,
Um,
so which of the following is the largest population to which the results of the survey can be applied? I think this question is based on rule number 3. So the results of the
yeah.
survey can be applied to the same population from which we've taken the sample. So option
So would it be like B,
D,
B,
B.
the for all fourth grade students at the school?
Okay, and why not D?
Because it doesn't talk about like from the county. It
Hmm.
talks about just like the specific school.
Yes, exactly. So here are I think 4th grade and the school. So here you have 2 parameters on the basis of which we have taken the sample. So one is the grade and one is the school. So the results will be only applicable to the 4th grade students and in the same school. If you change the grade, let's say if we apply the same result to 12th graders, now 12th graders might not feel morning announcements were helpful, so we cannot change the grade and we cannot change the school. So that's why it's not going to be option D. And although option A is correct, but it's not the largest population,
It's not the largest population. Yeah.
and it's not going to be option C because it says all students at the school. Now all students would include all the other grades as well, so option B is
Yeah.
correct. And then the other type of question, yes, questions like these. Now you have some results for the sample and we want to make the prediction for the population. So this one says that a city has 50 city council members. A reporter polled a random sample of 20 city council members and found that 6 of those polled supported a specific bill. Based on the sample, which of the following is the best estimate of the number of city council members in the city who support the bill? Okay, so here we had a population of 50 city council members, and from this population we took a sample of 20 city council members, and out of those these 20 people we found that 6 members supported a specific bill. So 6 out of 20 supported the bill, and we want to estimate that out of 50 how many members would support the bill.
So would it be like you have to like take the fraction and to like divide it, and then I got like 0.3, and then I multiply by 50,
Exactly. This
and
is a
then I got
simple
15.
proportion question. Exactly. 15 will be correct. So in these type of questions, first you just find out that what fraction of the sample is, supporting the bill. So it is going to be um, 3 over 10. And then to estimate that how many out of 50 would support the bill, we just, find out 3/10 of 50. So we'll get 15. Okay, so this is another type of question that you can expect, and this is actually, it's
Mm-hmm.
nothing more than setting up the ratios. Okay, you can set up the ratio, so
Yeah.
60 over 20 and x over 50. Okay, then the other type of question is based on margin of error. Yes, this one. Can you read this one?
A park ranger asks a random sample of visitors how far they hiked during their visit. Based on the responses, the estimated mean was found to be 4.5 miles, with an associated margin of error of 0.5 miles. Which of the following is the best conclusion from these data?
Hmm. Okay, so this is the estimated mean. And it has a margin of error of 0.5 miles.
Mm-hmm.
So let's read all the options one by one. It is likely that all the visitors hiked between 4 and 5 miles. Option
Mm-hmm.
B, it is likely that most visitors hiked exactly 4.5 miles. It is not possible that any visitor hiked less than 3 miles. It is plausible that the mean distance hiked for all visitors is between 4 and 5 miles.
Would it be D?
And why?
Because I feel like it's mostly like when they're talking about the mean distance it's hiked is between 4 and 5.
Hmm. Okay. Are you sure?
I was thinking it was either D or A.
D or A? D is correct. And let's see why A,
Mm,
B, and C are not correct. So option, first of
yeah.
all, estimated mean was 4.5, so, and margin of error is 0.5. So the actual mean could lie between minus 0.54 and plus 0.55. So the true mean or the actual mean could lie between 4 and 5. Now option A says that it is likely that all visitors hiked between 4 and 5 miles. Why this is not correct is, even if somebody is hiking for, let's say, 3 miles or
Hmm.
maybe 6 miles, if even if some
Yeah.
person is not between this interval, even then you can get a mean between 4 and 5, right?
Yeah.
Yes, so even if there is one value which is 3, even then you could
Hmm.
get a mean between 4 and 5. So this one is not correct. It
Yeah.
says it's likely that all visitors hike between no, it's, we cannot say that. So that's why option A is not correct, and for the same reason option C is also not correct. It says that it's not possible that any visitor hiked less than 3 miles. Well, it could be
Yeah.
possible if somebody hiked for 2.8 miles. Even then our
Hmm.
mean could lie between 4 and 5. It depends on the other values. That's
Yeah.
why option C is not correct. And then B says it is likely that most visitors hiked exactly 4.5 miles. This is definitely not correct. This is 4.5 is the mean, so it does not tell
Yeah.
us anything about the values, like what
Hmm.
is the distance people hiked. Okay, And now there are some really confusing questions. For example, let's take number 1. Yeah, this one. Okay, so this one says, in a study of cell phone use, 799 randomly selected US teens were asked how often they talked on a cell phone and about their texting behavior. The data are summarized in the table. Based on the data from the study, an estimate of the percent of US teens who are heavy texters is 30%. That's an estimate. And the associated margin of error is 3%. Which of the following is a correct statement based on the margin of error? Okay, so the estimate of US teens who are heavy texters is 30% and the margin of error is 3%. I think in this question we don't even need all of this information. I think. But let's read the options. Approximately 3% of the teens in the study who are classified as heavy texters are not really heavy texters. It is not possible that the percent of all US teens who are heavy texters is less than 27%. The percent of all US teens who are heavy texters is 33%. It is doubtful that the percent of all US teens who are heavy texters is 35.
Well, it, this one, is it D?
Are you guessing? Are you sure?
No, for this one because, yeah, no, it's not A. For B, it could be possible that it's less than 27, and then then the percent of all US teams who are just is 20%. That one, it's like too, like, because the margin of error could be, it's like from 27 to 33.
Yeah, it could be. So, like, margin of error is
Yeah,
3%, so the actual percentage could be between 27 to 33.
and
So this
yeah,
says that the percent of all this heavy text is 33. No, it could be between 27 and 33. So that's
yeah,
not correct. And it is doubtful that the percent of all US teens who are heavy text is 35. Yes,
yeah.
it is correct. Option D is correct. Okay. Okay, so, well, that is probability and conditional probability. There is nothing much to teach there. I'm sure you already know about probability, right?
Yeah.
Okay, so I'll just straight away go to the questions of conditional probability.
Okay.
In conditional probability, there will be always a condition. Okay, for example,
Mhm.
there is this question. This is easy. Let's do this one. So in conditional
Okay.
probability, there will be this sort of a table there in the question,
Mhm.
right? And you'll have to find out the probability of something given that given will be something else. So that this given thing will be the condition. Okay. So can you read this one?
The same 20 contestants on each 3 days answered 5 questions in order to win a prize. Each
Mm-hmm.
contestant received 1 point for each correct answer. Number of contestants receiving a given score on each day is shown in the table above. No contestant received the same score on 2 different days. If a
Mm.
contestant is selected at random, what is the possibility that the contestant selected such a contestant received a score of 5 on day 2 or day 3, given that the contestant received a score of 5 on 1 or 3 days?
Hmm. We have to find out the probability that any randomly selected contestant received a score of 5 on day 2 or day 3. Here is day 2, day
Mhm.
3. Given that the contestant received a score of 5 on one of the 3 days.
Okay. Um,
So we'll try to find out the desired outcome over the total number of outcomes. So what is the desired outcome in this case?
It's like the number of selected students that received a 5 on day 2 or 3 that also received a score of 5 on 1 to 3 days.
Yes, so how many, so that's a desired outcome. The desired outcome is the number
Mm-hmm.
of contestants who got a score of 5 on day 2 or day 3.
Mm-hmm.
So here is day 2, here is day 3, and this column is 5 out of 5. So how many received
So 5 students.
5 what?
5 got 5s on day 2 and day 3.
So that is the desired outcome because 5 people received 5 out of 5. 2 plus 3 we did. So
Mm-hmm.
5 received 5 out of 5 on day 2 or day 3. Given that the
Yeah.
contestant received a score of 5 on one of the 3 days.
Yeah. Score of 5 on 1 to 3 days. So then it would be 5 over 7.
5 over 7, exactly. So the answer is 5 over 7. And the other question is, yeah, this one you have, again, you have two variables. One variable is type of the car, and second is the
Yeah.
price of the car. So it says that
Mm-hmm.
the table above shows information about 14 cars listed for sale on an auto dealership's website. If one of the cars listed for sale is selected at random, now we are selecting at random from all the cars. What is the probability that the
Mm-hmm.
car selected will be a hybrid car priced at no more than $2,500?
It would be like 2 over 14, 1 over
2,
7.
yes, 2 over 14 or 1 over 7. That's correct. Okay, let's do another one. So the marble will be blue. No, this is easy. Tuesday, the 135. Okay, let's do this one, although this one also seems like the previous question.
On Tuesday.
Random on that date did not purchase gasoline.
So it would be like 50 over 135.
50 over 135, yes. Okay, let's try to find out some difficult question. Many of the male survey responded that they do not play a school. I think in this one they have given the probability. 100 students, 1,000 responses from the students surveyed. This one is also not that. There was, yeah, this is the one. In this one the probability is given and we have to find out a
Mm-hmm.
missing value in the table. Human blood can be classified into 4 common blood types: AB, AB and O, and it is also
Mm-hmm.
characterized by positive, negative. Okay, so if one of these people who is rhesus negative is chosen at random, the probability that the person has blood type B is 1 over 9. What is the value of X? Okay,
So that would be um would it be 8?
8. Yes, 8 is
Yeah.
correct. Okay, I think so, Kevin. We have finished probability and
Yeah.
statistics, everything in probability and
Mm-hmm.
statistics.